Okay, so welcome back, and today we're going to talk about graphs of sine and cosine functions. So I drew a couple of those functions, both of the functions, on the board, and so I'm going to discuss them. Again, my artistic skill notwithstanding, but I'll make it work. So the first one is a sine curve, and the second one is a cosine curve. So they're almost exactly the same. In fact, they're just shifted off to one side. So you have a sine curve that starts at 0 and it has this nice cyclic pattern. And then the cosine is basically the sine curve that's shifted over by pi over 2. So if you shift this point to here, then you get the cosine function. So these are what we call periodic functions. Okay? So again, you can see by this graph, as I mapped out the first so many values, and you plot them, you can see that it has this nice cyclic pattern, and you can see it also when you create the table of values, as you see here. And this just goes from 0 to pi. So this goes from here all the way here. And so you can see that the corresponding points, angles on the unit circle match to a point on the curve. Now, the nice thing about these is that these are defined for all real numbers. So this can go on for infinity in both directions. Also, you see that the value of x and y, right? So remember, cosine, sine is equal to what? So sine theta, let me write it this way. Okay. So you've got sine theta is equal to y, right? And then you've got cosine function. Cosine theta is equal to x, right? So you can see that the value of x, when you create the subsequent right triangles, the values of x go from what? 1, right? Starts at 1, the length of x, and as you go to pi over 2, it goes to 0, and then as you go to pi, it goes to -1. And then as you go from pi to 3 pi over 2, it goes to 1 again, right? Or excuse me, 0 again, because the x is shortening, and it goes to 0, and then as you go back to 360 or 0 again, it goes back up to 1. So you start at 1, and then you're back up to 1. Okay, so you can see that there's a one-to-one correspondence between a point on the cosine or sine curve and a point along the unit circle, as I've shown here. Okay, now, what else can I say? Okay, so there's the period, right? Since this is a periodic function, there's the period. So remember, the period is the smallest horizontal shift that gives you the exact same function. So P, which is again the smallest positive horizontal shift that gives you the same function. So in other words, f of x plus p equals f of x. So in this case, for sine and cosine, that shift is 2 pi. Because you can see from here, from there, right, it's at 0 to here where it goes back to 0. Okay? That distance is the period. Because if you take that and you shift it over, you end up getting the exact same function. Okay? So in this case here, for sine and cosine, the period is 2 pi. And you can see this as well, because remember, as you go around the unit circle, one revolution that brings you right back to where you started from is 2 pi, because that's the number of radians in a full revolution of the unit circle, of any circle. Okay, and so let's see, anything else I want to say here? Yeah, so the only other thing that I'd like to say is, again, for any wave, when you're talking about light waves, sound waves, or anything that moves in a wave, when you're talking physics or anything like that, the period, easy way to do it is just go from crest to crest, right? So from crest to crest, or from valley to valley, or like what I did was from 0 to 0. So anytime where it starts to repeat the pattern, that's the period, okay? So again, you could either measure it from, like I said, from here to here. So you can measure it from here to there, which is 2 pi, okay? Or you can measure it from here okay? That also gives you 2 pi. Okay, that's it. See you next time.